In third numerical problem, a metal whose work function is 3 electron volt is illuminated by light of wavelength 310 raised to power minus 7 meter. Calculate number A, threshold frequency, number B, maximum energy of photoelectrons, and C, stopping potential. Let's start to solve this numerical problem. Now, the given data is lambda, which is equal to 310 raised to power minus 7 meter. The work function which is phi equal to 3 electron volt. So just solve this electron volt to convert into joule. So we can write this also in the form of 3 multiply. The value of electron is 1.602 10 raised to power minus 19. So we can write multiply to this value with 3 and we get what? We get 4.806 multiplied 10 raised to power minus 19 joule. So now the work function, the value of work function is what? This. So we will consider the value of work function is 4.806 10 raised to power minus 19 joule. And the last thing in the given is what? Is the Planck constant. Is the Planck constant, which is H equal to 6.626 multiplied 10 raised to power minus 34 joule second. Now this is the given data. Now they want to find three things: threshold frequency, maximum energy of photoelectrons, and stopping potential. Let's start to find the values of threshold frequency, maximum energy, and stopping potential. So this is the given data. So the first thing is threshold frequency. So we have to find threshold frequency, which is equal to F naught, which is what? F naught. So for the threshold frequency, we have a relation F naught is equal to phi over H. So now this is very simple. So we have the value of phi and we have the value of H. So the phi value of phi is 4.806 multiplied 10 raised to power minus 19 joule divided by the value of Planck is 6.626 10 raised to power minus 34 joule second. So divide the both values and we will have F naught is equal to 0.72 multiplied 10 raised to power 15 hertz. So this will be the answer of threshold frequency. So the value of threshold frequency is 0.72 10 raised to power 15 hertz. So this is the value of threshold frequency. Now we have to find part B, which is the maximum energy of the photoelectrons. Let's start to find the value of maximum energy of the photoelectrons. Now part B of this question, which is, we know that kinetic energy maximum will be equal to HF minus threshold work function minus work function. Now we can write HF in the form of HC divided by lambda minus work function. Now we have the value of H, we know that the value of C, which is 3 10 raised to power 8 meter per second, and in the given the value of lambda is 3 10 raised to power minus 7 meter. Let's start to put the values, and we have what? 6.63 multiply 10 raised to power minus 34 multiply 3 10 raised to power 8 meter per second divided by the value of lambda is 3 multiply 10 raised to power minus 7 and minus the value of work function, which is 4.806 multiply 10 raised to power minus 19. So just multiply, divide and subtract the value, do it yourself, and after calculation of these value, you will get the value of kinetic energy maximum, which is equal to 1.824 10 raised to power minus 19 joule. But we have to convert joule into electron volt. So it is very easy to convert joule into electron volt. Just divide this value, to the 1 electron volt, So divided by 1.602 10 raised to power minus 19, and you will get this kinetic energy in electron volt. So kinetic energy maximum is equal to 1.14 electron volt. So this is the kinetic energy of the photoelectrons. So this is our required answer of the part B. Now we have to find part C, the stopping potential. So part C is we have to find the stopping potential. We know that kinetic energy maximum is equal to stopping potential, electron, the value of electron, and V naught. So V naught shows the stopping potential. So let's find V naught is equal to kinetic energy maximum. We already we know that the value of kinetic energy in part B. So divided by electron. So we know that V naught is equal to the value of kinetic energy is 1.14 electron volt divided by the value of electron. So we can see that we can simply cancel the value of electron in numerator and denominator. And we will get only 1.14 volt. So the stopping potential of the photoelectric effect is worth 1.14 volt only. Okay, so this is the answer of part C. So in numerical number 4